Okay, so we're talking about two-dimensional figures, and I want to first talk to you about what a polygon is. Now, the polygon is kind of a long definition, and I'm going to do my best to simplify it. I'm going to read it first, and we'll talk about what it means. It's a closed figure formed by a finite number of coplanar segments, such that the sides that have a common endpoint are non-collinear, and each side intersects exactly two other sides, but only at their endpoint. It's really a messy definition. But basically, it's made up of line segments. They only intersect at their endpoints. There's no curved parts to it, and it has to be closed. Okay? When you name it, you use the vertices to name it, and the vertices are where the line segments intersect. So, and you can name it going clockwise or counterclockwise. You don't want to skip all over the place. So, like this one, they went counterclockwise. It's polygon A, B, C, D, E, F. But you could go F, E, D, C, D, A. That would be fine. But you wouldn't want to flip-flop all over the place. Okay? Okay, so you name the polygon according to its vertices. Now, here's some examples of things that are polygons and things that are not. Okay? Notice this. On the left, we've got polygons. All of these are made up of line segments, and they only intersect at their endpoints. They're all closed up. But if you look over here on the right, you've got a semicircle. That's a curved part. That's not a polygon. This one's not even closed. This is the next one. Then we've got two lines that intersect. That's not a polygon. And then again, you've got an oval, which has a curved part to it. So those are not polygons. Now, there's two types of polygons that we want to talk about. There is the convex polygon, and there's the concave polygon. The convex polygon, you can do a test to determine if it's convex or not. Okay? And if you can take and draw a line along each one of the segments of the polygon, and it does not cross over into the interior, then you know that it's convex. If you come over here to the concave one, and like I could draw this one and I'm good, but then when I go to draw this, it goes into the interior, okay? And so that makes it concave. I also kind of know because it kind of caves in on one side, okay? That's another way to kind of think of it. But the line test will ensure that for you if you do it. Now, you can name polygons according to how many sides they have. And most of these you probably know. Like you have your triangle that's got 3 sides. And you can get more specific with the name, that we'll talk about this later on this semester. Your quadrilateral has 4. Again, those have more specific names. Then you have a pentagon. It's got 5 sides. You have a hexagon, has 6, and a heptagon has 7. Now, people tend to confuse these two, okay? And what I do to remember is 6 has an X in it, as does hexagon. So they both have an X in it, so they go together. I also think of like a hex, like 666, which is kind of weird, but anyway, I don't know, for whatever reason I think that, okay? So 6 is a hexagon, and 7 is a heptagon. Then you have your 8-sided figure, which is your octagon. It's like the stop sign, or an octopus has 8 legs, okay? So that's 8. And nonagon is 9. Now that's another hard one to remember, and I just remember that nonagon and 9 both have the same first letter. Then we have the decagon, which is 10. I'm going to talk about that one in a minute. Your 11-sided is your hendecagon. I've also heard it called your undecagon. To be honest with you, we don't talk about either that one very often. Your 12-sided is your dodecagon. Now, your 10 and your 12 get confused a lot also. So what I do to remember which one's which is dodeca has 2 more letters than deca, right? And 12 is 2 more than 10. So that's how I remember that the dodeca goes with the 12 and the deca goes with the 10, okay? And then anything greater than that, you just use the number of sides. So like it's a 13gon, or a 20gon, or a 25gon, or a 135gon, okay? So any more than the 12, you just refer to by the number of sides. All right, now, an equilateral polygon is one that has all sides that are congruent. Equi means equal. Lateral means sides. So it's got equal sides. Equilateral has equal sides. And then equiangular, again, equi means equal, and angular means angle. So that's a polygon with all the angles that are congruent. Then you have what's called a regular polygon. This is probably the most specific that you can get, because it is a convex polygon. It has to be convex. That is both equilateral and equiangular. So this right here is a regular hexagon. So if I say you have a regular hexagon, you immediately know that it's convex, it has 6 sides, and all the sides and angle are equal to each other. Okay? And they'll give you that description throughout the year, so you need to know what that means. All right, so it says name each polygon by its number of sides, then classify it as convex or concave, and regular or irregular. So we look at this one. It has how many sides? 5, so that makes it a pentagon. 5-gon. Gotta get a little more specific on that one. Okay, that's not until you get to 13 and greater. So it's a pentagon. Is it convex or concave? It is convex. And is it regular or irregular? It is regular because all the sides and all the angles are equal to each other. Good. All right, how many sides does this guy have? 7, which means it's a heptagon. Okay, is it convex or concave? It's concave. Oops, concave. And because it's concave, it has to be what? Irregular. Only your convex can be regular. All right, any questions on that? Okay, now what we want to talk about is perimeter, circumference, and area. Okay? Perimeter is the sum of the lengths of the sides of the polygon. Circumference is kind of like perimeter, but it deals with circle. Okay, it's the length of the circle all the way around. And then area is the number of square units needed to cover the surface. Now, when you think about perimeter, I always think the difference between perimeter and area. I always think if I was going to create a yard or maybe a dog kennel or dog pen, okay, and how much fencing I would need would be the perimeter. How much sod or how much dirt I would need to cover the inside is area. Okay, so perimeter goes around the outside and area covers what's on the inside. Okay, now let's talk about these formulas. Okay, I'm pretty sure you've used these before. Triangle, for perimeter, you just add up the sides. Okay, let's see. Area is half base times height. You might have used base times height divided by 2. That's the same thing. Okay. A square has 4 equal sides, so the perimeter is 4 times the length of the side. The area is the side squared, or length times width, base times height, but they're the same, so that's why it's squared. In a rectangle, you have 2 lengths and 2 widths, so the perimeter is 2 times the length plus 2 times the width, and the area is length times width. In your circle, your circumference is 2 pi r, or pi times the diameter, and your area is pi r squared. And I'm pretty sure Miss Ball and Miss Fry had some cool songs that you could sing for these, if you want to remember those and sing them all day long, okay? Pi r squared, pi r squared. Area of the circle, pi r squared. Okay, so you go in the O circumference one and all those, okay? All right, so we want to find the perimeter and the circumference and area of each one of these figures. This being a rectangle is going to be the perimeter and the area. Okay, so remember, perimeter is 2 times the length plus 2 times the width. Okay, so my length is 6 plus 2 times my width, which is 5.5. So that ends up being 12 plus 11, which gives me a perimeter of 23 feet, right? Okay, then we have area, which is length times width. Okay, my length again is 6, and my width is 5.5. If I multiply those together, I get 33 feet squared. Remember, area is in square units, and perimeter is just a linear length, so it's just feet, because area is feet squared. You guys done this before, yes? Yes. Okay, so then we got circumference, which is pi times the diameter. It gives me the diameter. So I'm going to take pi and I'm going to multiply it by 6.2. But I want you to find the pi button on your calculator, because I want you to use that button instead of 3.14. If it tells you to use 3.14, then that's what you need to use. Otherwise, use the pi button. If you have a calculator like mine, it's like the 4th button down on the left. And so you could just put 6.2 pi or pi times 6.2. And you end up with a circumference of 19.5 centimeters. Okay, area, pi r squared. Now, it gives me the diameter. What's my radius going to be? What? 3.1. It's half that, isn't it? So I'm going to do pi times 3.1 squared. And you can type that in your calculator. Pi times 3.1 squared. And what do you get? What do you get? Nobody got anything, huh? You still typing it in? 30.2. Okay, 30.2. And that would be in centimeters. So there's my circumference, and there is my area. Remember to show your work. Your homework. All right, any questions on that? All right, now let's look at this next one. It's kind of a long problem. It says Darren has 32 feet of fencing to fence in a play area for his dog. Which shape of play area uses most or all of the fencing and encloses the largest area? So we got 32 feet. We want to use as much of that as possible and get as big of area as possible. So we got to check each one of these. Okay, so we're going to check the circle first. It says it has a radius of 5 feet. So my circumference, which is pi times the diameter, I'm going to do pi times my diameter, which is 10. And if I do pi times 10 or 10 pi, it's going to be about 31.4. That uses almost the fencing, doesn't it? Then I want to look at the area, which is pi r squared. Okay, my radius is 5. What does that get? Pi times 5 squared. Anybody got it? 78.5 feet squared. Okay? Alright, now I got to do these others and compare it with this one. Okay, so part B, it's got a rectangle that's got a length of 5 feet and a width of 10. Okay, so a length of 5 feet and a width of 10. So my perimeter is 2 times the length plus 2 times the width. So it's 2 times 5 plus 2 times 10. So that's 10 plus 20, which is 30 feet. Doesn't use quite as much fencing, right? Well, let's see what happens with our area. Remember, area is length times width. So that would be 5 times 10. That gives me an area of 50 feet squared. What do you think? Should we think about that guy, or should we go with the first one? Okay, so we're going to get rid of this one. Okay, that one doesn't meet our criteria as well. All right, then we have a right triangle with legs of 10 feet each. So we have a right triangle, and we have legs that are 10, right? Now, to find the perimeter, I need to find this third side. What's this third side called? Remember? C. It is C, right? It's called the hypotenuse, right? And so to find it, what am I going to do? Because I need to know this for my perimeter. What do I use to find that third side of a right triangle? Huh? Anybody know? What? A squared plus B squared equals C squared. What's that called? Pythagorean theorem. You said that? Oh, no, you told me it was C. Well, it is C, you're right, but I wanted to know the real name for it. Okay, so A squared plus B squared equals C squared. So I've got 10 squared plus 10 squared equals C squared. 100 plus 100 equals C squared. That's 200. Take the square root. And the square root of 200 is like, what, 14.1? 14.1. Okay, so my perimeter is going to be what? What is that? What's my perimeter? 34.1. Okay? What does that tell me? That's too much, isn't it? Do I have that much fencing? No, so I don't even need to find the area. It's out. Okay? Piece of history. Alright, so that was part C. Then we're going to look at part D. It's a square, and it's got side lengths of 8. So my perimeter would be 4 times 8, which is 32. That's exactly the right number of fencing, isn't it? Okay, so 32 feet. Okay, so now we'll look at the area, which is side squared. And so 8 squared is what? 64 feet squared. Okay, so what do you think? Should we go with this one, or should we go with our first one? If it was my dog, I would want to give him more room to play, wouldn't you? Because this one's going to give him about 14 and a half more square footage to play in, isn't it? Okay, even though it doesn't use quite as much fencing. It's enough, yeah. It's pretty close. Yeah. So this guy's out, and we're going to go with a circle with a radius of 5 feet. I guess you're challenged it with to create a circle for fencing. Oh, that might be kind of hard. Find center and go all the way around. All right. Okay, last one. Find the perimeter in the area of triangle ABC with the vertices. Okay? Now, if it were me and I was going to do this problem, if it gives me points, I'm going to graph it. And I'm going to graph it on graph paper. Okay? Because if you try to sketch it, it makes it really hard to count. It's easy to make a mistake. And another reason is sometimes we get horizontal and vertical lines. All right? And if you have horizontal and vertical lines, you can count, right? If you don't, if you have a diagonal, what are you typically going to have to do in order to find the length? The distance formula, right? We don't want to have to do that a whole bunch of times unless we absolutely have to, correct? Okay, so this one I can count. It's 1, 2, 3, 4, 5. And here is 1, 2, 3, 4, 5, 6, 7. Now, here, I could do the distance formula, but what kind of triangle is this? A right triangle, so what else could I do that might be quicker? A squared plus B squared equals C squared. So I could use the Pythagorean theorem since it's a right triangle, couldn't I? That saved me a little bit of time, I think. Okay, so this is my A and my B, and then this is going to be my C. So I'm going to do 5 squared plus 7 squared equals C squared. So 25 plus 49 equals C squared. And 25 plus 49 is 74 equals C squared. And take the square root of that, and so what does that give me? 8.6? Okay, so that third side is 8.6. So then to find my perimeter, I'm going to do the 8.6 plus the other two sides, which are 5 and 7. And so what does that give me? What does that give me if I plug that in? 20.6 units. You don't know if it's feet, yards, inches, whatever, just use units. Okay, so there's my perimeter. Now I need my area. What's the formula for the area of a triangle? Base times height divided by 2. So my base is 5, my height is 7, and if I divide that by 2, I get 35 divided by 2, that gives me an area of what? 17.5. And that's in units squared. That's fine. Any questions? I think a lot of this you've done before, maybe a couple of different things that you can look at, but overall I think it's maybe the first page. A couple of that time, not a bad. Alright, so your assignment is page 61, 12 through 48.